Oh, sorry. And returning that into something that's valuable, right? Making value out of waste streams. So kind of one of our most widely known projects is the Omni processor that was worked on with the Bill and Melinda Gates Foundation that was converting human biosolids into electricity, water, and yeah, electric. Don't know if someone's saying something.
No, you continue.
But yeah, so that was, kind of our past project, and that's what got me really excited about this. And then currently I work mostly on process design and continued operations support for our existing process.
Great. Well, thank you, Stephanie. Wylie, why don't you give a 2-minute introduction to yourself?
Hey everybody, I'm Wylie. I graduated from UW Chemical Engineering the same year as Steph did, so in 2020. After graduation, I joined a local company, a pretty small startup. I was their first employee, called BlueDot Photonics. So we are a group that spun out of a lab in the chemistry department here at UW, and we are working on commercializing a new perovskite material to make existing solar panels more efficient. So essentially getting more power from sunlight than normal solar panels currently do. So let's see, today I work mostly on the physical vapor deposition of very, very thin films of our material. So that is a lot of process optimization. I also participate in materials design and help guide which formulations of materials we decide to turn into thin films, and then support the team through building up data science infrastructure and data pipelines to help expedite R&D. So that's kind of all what we're focused on right now. We've got a pretty small team moving towards a very small singular goal. Basically demonstrating that this project is feasible, reproducible, and economically viable is the biggest thing. So a lot of chemical engineering in my day-to-day, really across everything I've learned. It's pretty fun to use, and I'm excited to see where the product goes. We're only a couple of years into it, so it's been a lot of fun.
Great. So now we'll move into a few set questions. And Wylie kicked us off very well, because the first one we want to ask about is part of the point of this panel is to give some of our students sort of a take on what their experience might be like transitioning into these fields of energy, environment, and sustainability. So could you tell us just a little bit about what your day-to-day looks like in your current role, and how has that changed really since you transitioned into that role? Maybe Wylie, since you just started talking about that a little bit, maybe we'll start with you and then let Stephanie go. You're unmuted. You're muted, correct?
I think you're muted.
Oh. I think maybe we'll let Stephanie. Oh, no. Okay, perfect. There you go.
Yeah. So day in the life, is that that was the question?
Yeah. What's your day-to-day like in your current role?
Perfect. So my title is photovoltaics engineer, and that's pretty broad. So photovoltaics is just basically like the fancy word for solar. So that's my job title, and it really encompasses a lot of high throughput R&D. So when on this week I got up and I get into lab, and then I start preparing for experiments. So that's getting into the glove box to weigh out specific types of materials, planning experiments around those materials, and then coordinating with the downstream team. So I'm upstream. I use the physical vapor deposition techniques, which is basically heating up those materials really, really hot under vacuum and getting them to sublimate and turn into a thin film on glass. So I make those samples, and then I hand them off to the downstream team, where they do different post-synthetic modifications to the film and characterization as well. So really day to day, it's most of my time is spent running experiments, planning experiments, and coordinating with other team members. And then kind of throughout the whole week, I'll be amassing data. So it'll usually take like a day or two at the end of the week to sit down and really work through the data collected and make sense of the results and guide the next week of experiments. So really kind of on the fundamental R&D side of things in industry. Yeah.
Great. Stephanie, what about you?
Yeah, so a little bit different. So at Sedron, we have a kind of a full-scale plant in operation, but we also don't have the luxury of very many chemical engineers. So my day-to-day is kind of trying to fill all of the roles that a chemical engineer should be filling for a processing plant. So it's been a great opportunity, but also kind of a interesting mix of things. But I've, on a day-to-day basis, I might be working on researching a new concept or researching why XYZ doesn't work and trying to figure out some more details behind that. Working on designing the next version of our system and looking at more of the broader scale process design. And then it also might be sitting in a quantity of meetings and, trying to add a chemical engineer's voice into the void of, equipment design. And then also my favorite part of my job currently is working with existing operations and filling more of a process engineer role. So monitoring operations, troubleshooting problems that go wrong, and doing kind of larger scale analysis of how we're doing, where we are currently, and how we can get to our ultimate goals with the process.
And so it sounds like kind of a range of kind of research to process engineering, which is wonderful because it means we have a wide variety of different perspectives. So maybe the two of you could tell us a little bit about how chemical engineering, or maybe even just the broader skills that you gained in our program, have been useful in your current role. So how does that ChemE work inform the work that you're doing now? And maybe Stephanie, you could start this time.
Yeah. So chemical engineering, it's interesting because I think that the chemical engineering class and kind of skill set that I use most often on my day-to-day work schedule is the process design class at the end of your ChemE curriculum, where you kind of put it all together and try and make sense of it. And that's definitely the kind of skills that I'm using more on a day-to-day basis. Is, there's separation principles and there's phase equilibrium principles, but putting it all together and trying to kind of conceptualize a larger picture with it.
Great. Wylie?
I'd say if I had to think back to specific chemical engineering classes, I think about mass balances a lot, and then molecular scale transport. So in my day-to-day, when I try to make these thin films, everything is on the order of nanometers. So I'm trying to take this material and turn it into something that's tens to hundreds of nanometers thick, and really balance what material is where. So as you can imagine, trying to do that with any sort of macro scale techniques, it's quite difficult to precisely organize thin layers or atoms. So it's really going back and understanding how materials behave under different environments to get them to go where you want to go. So let's see, mass balances, some thermo, some transport as well are kind of the really big things. I also use a lot of Python on my day-to-day to kind of guide experiments, guide simulations that inform experiments, and really analyze a lot of data. Those are kind of the really critical parts of my job that I can attribute to things I learned in chemical engineering.
So I guess kind of extending off of these points, I'm sort of curious how you kind of went from these kind of chemical engineering focused fields to the specific field you're in now, and sort of what's inspiring you about working in this energy and environmental sector. Because the chemical engineering curriculum is quite broad, and so then transitioning to these more specific areas is maybe not an obvious transition. So maybe you could tell us a little bit about kind of how you transitioned from the ChemE curriculum to where you're at now, and kind of what's inspiring you about some of this current work. I'll keep the pattern. So maybe Wylie, we can start with you.
Yeah, definitely. So let's see. Going into undergrad, I knew I wanted to do something on the environmental side to fight climate change, et cetera, et cetera. And I found chemical engineering was a really good option to build technologies that would actually be used by everybody, by people, and would kind of change the way society uses energy and reduce its dependency on unsustainable fuel sources. That was kind of the really big overarching goal that I thought chemical engineering would get me. Luckily, I found that to be true. Once I got into the program, I started learning about solar and new solar technologies, and did an internship down in the Bay Area with a solar company, as well as did a year's worth of research in the Hugh Hillhouse group on studying perovskite photovoltaics at a fundamental level and like how they work, how they degrade, and why there's such a high potential for impact for them. So basically, building on that wealth of experience, I looked out and saw what solar companies were starting right now around the perovskite space. It's a fairly nascent field and industry. So I was fortunate enough to find BlueDot Photonics. They're in Seattle, right on campus. So I was able to work with them and continue to kind of build technology that will reduce CO2 emissions. So I think that's something that I'm driven by, and luckily the whole team is driven by as well. Getting this product to market as the possibility to reduce like tons and tons of CO2 emissions at scale. So that kind of inspires me. That target is what keeps me going every day.
Great. How about you, Stephanie? What led you kind of from your kind of general chemical engineering curriculum to where you're at now, and kind of what's inspiring you about what your current work is?
Definitely. So similar to Wylie, I definitely had the overarching goal of having a positive impact, and I didn't really know how that would happen, but that's something that I wanted to do. I chose to do chemical engineering because I found that it gave me the most, kind of breadth of options. And because I didn't really know exactly what industry, et cetera, I wanted to work into, that was a good decision for me because it opened up a lot of doors. Specifically for where I work currently, this was kind of just a random chance of fate. One of my classmates at UW did a presentation on the company that I currently work for in our technology presentation for our engineering English class or something silly like that. And I was like, oh, that's really cool. And that kind of gave me the name recognition. And then, I stumbled upon them at a career fair and had a conversation with them, and they ended up, offering me an internship. And then through that internship, I was able to kind of learn how working at this company could give me that impact that I was looking for. And kind of the thing that really excites me about my current role is the technologies that we're working on. They have kind of a lot of varying areas of impact, from anywhere from pollution. That's kind of a really big one, is diverting streams from pollution, or from causing pollution. And then also, offsetting synthetic fertilizer emissions and kind of reducing the emissions associated with different waste streams, such as cow manure, which is one that we work on a lot right now. And there's kind of a lot of opportunity with the technology that we're working on currently, which is very exciting. And then also the team that we have that I work with has a lot of ideas that we're not working on right now. So the potential for the future is really exciting as well. What we might be focusing on primarily in 5 years might be different from what we're focusing on right now, which is definitely a lot of potential, which is exciting.
So a common thread that I'm hearing is that you sort of had some general sense, both of you had this general sense of wanting to work on energy and sustainability, but didn't necessarily know exactly how that was going to manifest until you joined the major. Could you maybe you both elaborate a little bit more on kind of what drew you to chemical engineering in the first place, and sort of win the recognition of, oh, actually, I'd love to apply this towards sustainability and energy. When did that happen? Was that sort of before you joined? Was it during the major? Maybe you could talk just a little bit more about kind of a timeline for that. Stephanie, maybe you could start.
Yeah, so I kind of decided to do chemical engineering more or less on a whim. It wasn't something that, had a lot of kind of existential thought behind it. But then once I was in the chemical engineering degree, I think it was in 310 where we were, doing mass and energy balances. And it was just so, I think it just all felt so interesting because it was kind of a combination of math and science and physics and, really, yeah, I think that it was mostly kind of the excitement around the classes, and then also the potential for I could work in pulp and paper, or I could work in oil and gas, or I could work in a million other industries that might not even know what a chemical engineer is, but I'm sure I could help them out. And I think that was kind of a message that was communicated to us a lot in the program, but then also, I think.
Great. And Wylie, do you have any thoughts?
Yeah, so let's see. I knew I wanted to do something around energy and sustainability going in, but I really wasn't sure how to apply that, or essentially like which major to choose. So I tried a couple law classes, thinking about doing like environmental justice law. Didn't like that at all. I talked to some atmospheric chemist professors to try and study atmospheric chemistry and like how CO2 emissions is influencing our atmosphere. And I think eventually I signed up to go to some grad student networking night at it was like a happy hour, and I wasn't even 21 yet. So I had to like agree with the organizers that I like wasn't going to drink if I went. And this grad student event was all people working in the energy space, and kind of giving them a chance to mix and talk. And it was there that I just I found myself, I didn't really know what I was going into, but I found myself just talking to grad students and about the work that they did. And kind of the most interesting conversations I had was with chemical engineering grad students. I really liked the problems that they worked on. I liked how for everything that they worked on, there was like a clear application. Like, oh, this is how we build a product out of that, or this is how we will use that to address these specific aspects. It wasn't so much on the fundamental side of basically understanding like, why does this work, or what is exactly going on here, but it's like, how can we take these understood phenomena and build them into something that will cause impact at scale? So that's when I knew I wanted to choose chemical engineering as opposed to, say, chemistry or physics. And yeah, basically working off the goal of doing energy and sustainability kind of led me down the courses and the path and the experiences to where I am today.
I think when I speak with a lot of students, I hear many of these similar stories where students, some of them know in advance, oh, I want this specific area. But many students, I think, come into the major thinking, oh, I kind of like the subject chemistry, math, and engineering. That sounds good. And then sort of come into understanding, oh, this is actually a really cool area of impact that I'd love to be involved in. And so it's great to hear you can find that path after joining the major, and it works out very well. Maybe as kind of one final question before we transition to the open questions is a much more technical one, which is maybe the two of you could tell us kind of what the biggest challenge is in your field and kind of why you think it's important. So maybe Wylie, we could start with you.
Yeah, so the biggest challenge in my field right now, so the field of perovskite photovoltaics or perovskite solar is really driving costs down to the point that it can compete with silicon. So if you look around, all the solar panels you'll basically see today, like on roofs and solar farms, that's all silicon. And silicon is a well understood process. It can be made at this point extremely cheaply. So it's basically finding what ways all these different perovskite companies, we're all like pretty small, are working on different aspects of trying to do the same thing, which is how can we either make our product cheaper and compete economically with silicon, or how can we work with silicon to further drive the cost down by making more energy for a single solar panel. So that's really the biggest challenge, is finding ways to basically sell the economics of the material. Yeah.
And Stephanie, how about you?
That's actually really interesting because it's kind of the same story for me. So thinking generally, Sedron works in a few different spaces, but thinking in kind of the nutrient recovery space, that's taking a waste stream and trying to recover nutrients from that waste stream for reuse, and to offset nutrient production in other areas like synthetic fertilizers, etc. And probably one of the biggest challenges that we face is keeping our technology financially feasible. Right now, we primarily are, kind of lucrative in the agricultural sector, and our system costs more than most farms, like the entire farm operation. So to sell that to a farmer is a really big ask. But it's fairly complicated technology. It's not there aren't a lot of clear ways to cut costs, but I think that's probably the largest challenge that we have, especially moving from kind of the sectors that we work in right now to other industries. To apply our technology there is just the initial cost of the operating cost of our systems.
Something I find, sorry, where did you want to add something?
Yeah, just to follow up on something. This is a small anecdote. I think in 310 they start telling you, so this is the first chemical engineering class. You may be in it or will be joining, etc. But like one of the very first things that they tell you is like price drives everything. And I remember not putting much stock in that at all. And you hear it more and more, especially as it comes into like process design. And then you get to the other side and you go to graduation, you start working at your first job, and that's like the bottom line. I think it makes sense thinking back on it now, but I remember not putting much stock in that initially.
I do think it's interesting that we kind of have many of these technologies and we don't realize that it's not just that we have like finding and making the technology, it's really making it cheap enough to be used in all of these sectors. So it's really interesting to hear you both say that same thing. So I think now we're going to enter the kind of open question and answer section. Elizabeth, I'll rely on you to field questions from the audience in person. If you have a question, please feel free to add it into our chat box or use the raise hand feature in Zoom and we'll call on you. And for Stephanie and Wylie, if you want to answer a question, use the raise hand feature and I'll call on you to start us off. So the first question that I see is, when did you start thinking like an engineer? Do either of you want to take that?
I'll go for it. I don't think I remember as like a very specific moment I did, but I remember when I did start annoying all my friends because I kept using like terms that I learned like in my chemical engineering classes, just like in regular conversation, and they got really frustrated. But it was like the most efficient way in my mind to describe like, I don't know, whatever we were talking about. And I think that was maybe after like a quarter or two of chemical engineering classes where I would say I started thinking like an engineer. If I had to draw a line.
Yeah, I feel like if I started thinking like an engineer before I graduated, it was probably in process design, working on, the first like concrete project where we were, coming up with ideas ourselves and connecting different classes that we had taken over the years.
There's a question directed specifically at Wylie, but I think maybe you both can answer it, which is, are you happy working at a startup? And how do you think it compares to something more established? Do you have any thoughts on that?
Yeah, so let's see. I can answer the first bit. So I'm really happy working at a startup. I did an internship at a small startup, and I really like the atmosphere. So I found BlueDot as a full-time position after graduation. Like I mentioned earlier, it's a really small team, so we're just 5 people, and we all work together pretty much daily. And I get to work directly with the CTO, the CEO. I get to be kind of intimately aware of everything going on on the business side and how that is guiding our decisions with R&D. I really like it because everything I do is so varied and also so high impact. A lot of the choices I make are kind of decisions made across the team about how how we can move most efficiently and most make the best R&D decisions to get to commercializing our product the fastest, which at times can be a little stressful, but also it makes the work I do feel all the more impactful. Yeah, I like it a lot. As for the second part of the question, which was how does it compare? I haven't worked at a company larger than 10 people at this point in my life. But I think from what I understand in conversations with peers, you don't have as direct line of access to the people, I guess, at the top of the chain. And this is maybe just a product of how small the company is, but I really like being able to have all these conversations with kind of everybody in the company, understand their experiences and learn what they're focusing on, all as part of our broader goals, which maybe wouldn't quite happen at a company of 1,000 people.
Really, yeah. Sedron is kind of in this weird space of, we were a startup like arguably maybe 2 years ago, and now we're kind of transitioning out of the startup space and trying to scale the company and scale the technology. And I think that generally, like Wylie, the experience has been very positive. We also have we have easy access to all of our higher ups at the company. I have, one-on-one meetings with the CEO very frequently, which is interesting. And I think that's very different from what you see at maybe a 200-person company. But in general, I think that the main difference for me has been the time scale between concept and execution is very short. And that can lead to really quick progress, but that can also lead to a lot of mistakes. And I think that the main difference between my company currently and where I think we'll be in a few years is having more of an established design process and really having steps and more checks and balances to make sure that we're doing the right thing before we do it. Yeah.
A follow-up from, Wylie, did you have something you want to add? A follow-up for me actually is, because I've heard from people that have joined startups or joined big companies, and it seems like there's a bit of a trade-off where if you're working for a big company, the potential for impact could be much larger because you have the resources accessible to a large company, whereas you also have less control over the technology because you're kind of driven by shareholders or other management. Do you feel like it's maybe easier to have, or do you feel more optimistic about your impact on energy and sustainability from the position of a startup? Do you think that your ultimate goal might be to be acquired by a larger company so that then you have the resources of a larger company? Any thoughts in that direction?
Yeah, I'll start with that one. So at BlueDot, a lot of kind of our founding techno-economic analysis. So that's basically the math behind, will this product be viable? Like, can we build this and sell it and like make profit? A lot of that techno-economic analysis included the CO2 reduction. So we have very clear estimations of at what point in our scale out and scale up of our technology we will be hitting certain emission threshold or emission reduction thresholds. So I think from a broader impact point of view, our work is very clearly moving towards these specific milestones, which I find very exciting and sort of a driving force. As if we were a larger company, could we potentially do that faster with the resources that a larger company may have? Maybe. But I think what's exciting is we get to make a lot of the decisions amongst the team, basically. We get to make guiding decisions about the company and about our product as 5 people. While our goals may be very clear, how we get there is something that we get to decide on. Yeah.
For sure. Yeah, I think that to answer that question as well, I think the main difference on impact has been, I have more impact at the company given that we're so small. But I think that we could have more impact if we were much larger. But I also think that we have a fairly risky technology. It's not fully flushed out. It's not, it doesn't necessarily check all of the boxes of kind of a larger company. So I think that if we were larger, we wouldn't be working in this space, which is kind of interesting to think about. We're going to, we have a path forward, and we have changes that we're making that make it better every day. But at the same time, someone who's looking for their 8% return on investment in 20 years, and, it's got to be better than the bank, they wouldn't necessarily throw all of their money at us right now.
Really interesting. Yeah. There's a question from a direct message to Elizabeth, which is, what was the job search process like for each of you? How did you approach your job search process and find connections in this energy and environmental area? And maybe Stephanie, if you want to start.
Yeah, so I think that my biggest recommendation to anyone would be to not be afraid to put yourself out there, because it doesn't hurt if you don't, you'll never get the opportunities if you don't try, is something that, you'll hear a lot, but it's really true. The way that I actually got my job is, I had my internship, and that's how I got my job. But the way I got my internship was and Nicole will tell you not to do this, so take it with a grain of salt, but I just connected to everybody on LinkedIn that had a degree from UW Chemical Engineering, just serial connected. I didn't send a message. I just connected with them. And then when I saw this job opportunity pop up, I looked in my connections, and I was like, oh, this guy, he works at Sedron Technologies, and he's a chemical engineer, and we're connected. And I sent him a message, and I said, hey, I'd love to hear about, your experience at Sedron Technologies. I have an interview next week. Can I pick your brain? And he was at first are you what? And I was like, please, I want to know all of these things. And, we had a phone call, and in that phone call, I was able to demonstrate that I was really interested, and I was really curious, and I, had prepared questions, right? And he went back, and, he later became my supervisor, so I know this story, but he went back to the hiring manager and was like, yeah, let's just hire her, because I've never had anyone ask me to do an informational interview before. And it's really easy, as long as you can get a past that initial step of being like, oh, I'm scared to ask someone to take time out of their day. It really goes a long way. And worst case scenario, if you do an informational interview with someone, you just learn something. It's not, you might not get a job out of it, but you'll definitely learn something, which is really good.
Just as a small plug, I also love informational interviewing. And I think at one point in the near future, I'm giving a small workshop on it to, I think, the mentorship teams for 310. So I completely agree. It's a great resource, and I'd love to tell you more about it in a few weeks. Wylie, do you have any thoughts?
Yeah, well, first of all, I second what Stephanie said. Really do not be afraid to put yourself out there. Ask a lot of questions, ask random people questions. The worst thing you get is a no, which isn't that bad in the grand scheme of things. And the best thing that you can get is a job, as Steph has shown. So for me, I would really advise to leverage on-campus connections. UW is a massive research institution, and they, depending on who you talk to, they will have connections all around the world. So my junior year, I worked as a research assistant at the Washington Clean Energy Test Beds, which is kind of a scale-up facility that is focused on, or that is really there for both research groups on campus and early stage startups to use. So I worked there as a research assistant, kind of helping out with lab work and working on some projects for the staff of the facility. And then I would ask my boss to introduce me to the companies that he interacted with. So these were the small startups that would come and ask about the facilities, or would come and use the facilities, or kind of any sort of connections that he had. And after those introductions, basically he would go out and say, this is a motivated student looking for a position after he graduates. Some of these companies would come back and say, oh yeah, we'd love to talk. Maybe it would be an informational interview, or it'd be like, hey, yeah, we totally have a job position open. Here's the application link. We'd love to learn more about you. That's how I found my way to BlueDot, which was a pretty great connection. So yeah, leverage your connections. everybody knows somebody, and eventually you'll meet someone who knows someone where you want to work.
We're getting a ton of questions, which is wonderful. I'm going to take one from the in-person crowd, which is, have you made a mistake during your job? And if so, how do you adjust to recover from it?
Yeah, I can start with that one. I have definitely made mistakes. I'm a very new engineer, and I'm given a lot of responsibility at my current company, which is an interesting combination. And I think one of my probably just most recurring mistakes and least impactful mistakes is interpreting specifically simulation results too early. I do a lot of Aspen simulations, and you depending on what class you're taking right now, you might have varying familiarity with Aspen, but if you put garbage in, you're going to get garbage out 100% of the time, right? If you are operating under incorrect assumptions, then your results are not going to be valid. And I have, run into the mistake a few times of, not thinking through my results fully before communicating them to the team. And then later I'm like, oh crap, that's not right. And then the best thing to do, one thing that my CEO always says is, bad news doesn't get better with age. So, I made a mistake, everybody. Sorry. I'm going to correct this. Disregard what I just told you. And it's been pretty, there hasn't been a lot of recovery. We're pretty forgiving at my company, partially because we operate so fast. There aren't enough checks and balances to prevent everyone from making mistakes, but definitely something that happens.
Yeah, again, second Japanese mistakes are very normal, especially as just coming out of your undergrad degree. Actually very little relative to what you will know after just 6 months working at your position, and mistakes are just part of the learning process. So let's see, mistakes I've made range from kind of more acute, where I've dropped a vial of lead material on the ground and it's just exploded. And I have to figure out how to clean, or I basically go read all the documentation about how to clean that up safely and efficiently, and then talk about how we prevent that in the future with my coworkers. So that's learning experience there on handling materials in lab. And then another mistake that I made a lot initially was kind of translating the data right into, or let's see, I call this a mistake, but this is just part of R&D. Is just basically translating your data into what decision to make next and what experiment to investigate next. So you can really, you can interpret your data the wrong way. And then maybe that's because you thought the data was very clear and you didn't get a second pair of eyes on the conclusions. So leveraging a team around you to help analyze and make decisions is a great way to mitigate, I would say, R&D directional mistakes. But again, all learning experiences. I design a way better experiment now than I did a year ago. So.
We're getting close to the end of the Q&A, but maybe just very quickly in 1 or 2 sentences, there's a question. Are there any other interests you plan to explore in your career in the next 5 to 10 years? Just really quickly, 1 or 2 sentences, maybe.
Yeah, I'll go for that. So for me, going into the startup position after graduation, I knew I always wanted to return for a PhD. So in the fall of 2023, I will be going back to get a PhD in chemical engineering at Stanford. And yeah, so David, looking good there. One of the groups I'm really excited to work with does a lot of catalysis work and electrocatalysis work. So we have now almost an abundance of renewable energy that we don't really know what to do with. The battery storage isn't quite there to basically capture all the energy we produce in a given very sunny day, for example, by solar. And so catalysis and electrocatalysis is a really exciting field where they're looking at ways to, for example, take those renewable electrons from solar and combine them with atmospheric species like carbon and water to get usable fuels out of them, like methanols or hydrogen. And that is another way of storing energy that we produce through renewable resources. That is a field I'm really excited about getting into.
Some of the work that we do in my lab too. Stephanie, one or two sentences. Is there anything, any other interests that you want to explore in the next 5 to 10 years?
Yeah, I think stepping kind of away from the technology side, I'm very interested in exploring more management positions and more mentorship roles within the company that I work in.
All right. Well, I think we should transition now into the lightning round. So we just have a couple quick rapid fire questions. The goal is to hit kind of only 1 or 2 words for each of these. What is a habit that contributes to your success? Maybe Stephanie, you can start with you.
Asking questions.
Getting enough sleep. Definitely getting enough sleep.
Those are great. What's your favorite part about being a chemical engineer?
Problem solving.
Interdisciplinary problem solving, using a lot of different ways to solve your problems.
It's hard to get it in the. And then who is your go-to mentor when you're seeking career advice?
My supervisor.
Also, my supervisors at BlueDot. Yeah, they've got a lot of great experiences, so to get to learn from those.
And then one more quick one, maybe not in 1 or 2 words, but what's your favorite memory from your time at UW Chemical Engineering?
My favorite memory is sitting in the computer lab and banging our heads against the wall, working on 310 problems and thermo problems and fluid problems, and but building the community associated with our study groups. And Wylie and we studied together pretty often.
Yeah, I second Stephanie on that. That was a lot of fun. Maybe in it not so fun. Some late nights in the computer lab, but looking back on it, you build a lot of great connections and you make a lot of friends. And there is definitely, you grow pretty close with your community when you're working on a lot of really hard problems.
Well, wonderful. Well, I think we're coming close to the end of our time. So let me just first say that it was wonderful to have the both of you here as panelists today to talk to our students. It was great hearing about kind of some of the various different ways that you're using some of this chemical engineering technology in the renewable and energy space. I mean, it's fascinating to see these various different, like from process engineering to more research side and lots of different ways we can apply it. So maybe we as a group can thank Stephanie and Wylie for spending their time with us. I'll give you a virtual applause. Yeah, and so thank you so much, and thanks to everybody for participating. We appreciate your time.
Yeah, thanks for having me. It was a pleasure.
Yeah.